Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded from Module 1 to Module 3 of the subject. If you want to watch it or if you have not watched, you can go check out my channel. All the modules of Module 1 to Module 3 are there. In Module 4 also, first chapter is done. In second chapter, some of the topic I've already covered. In this video, we'll see a new topic. I've already completed concepts of stability and necessary conditions for stability. Now in this video, I'm going to cover root stability criterion. Using root stability criterion, how to find the roots. Okay, using this stability criterion, we will know. And there are some problems also present on it. See, root stability criterion is based on formulating array, okay, or table called the root array using the coefficients of the characteristic equation. As you know, there is some characteristic equation present. For that characteristic equation, root stability criterion is based on what? You formulate some array or a table like this called root array using the coefficients of what? Characteristic equation. These are coefficients, no, a0, a1, a2. Using those coefficients, you are going to form a table. That is nothing but root stability criterion. Once the root tabulation is completed, the next step in the application of root criterion is to investigate the signs of the elements in the first column of the root array. Okay, first we will say how to write the root array. How to write, first what you will do, from the highest S value, highest S value, S power 8, S power 7, S power 6, S power 5, S power 4, 3, 2, 1, 0. You will write. After writing it, you are going to write the coefficients which are present in this way. First A0, then A1, A2, A3, A4, A5, A6, A7, A8. Okay. I'll repeat. First you write S, that is S8, S7, S6, S5, S4, 3, 2, 1, 0 left side. Then in the inside table, what you will write? The coefficients. How you will write? First A0, A1, then A2, A3, A4, A5, A6, A7, A8. These are the coefficients. In the place of A0, if it is 1, we'll write 1, 2, 4, 6, like that. Okay. After writing it, there is some calculation required from the next. Till the last number you will write. After writing in the first two rows, then what you will do is, we need to multiply A1 into A2 minus A0 into A3 by this A1. Okay. Then for the next calculation, this will become what? B1. Let us consider a B1, some value. For the next, I'll take one more color. A1 into A4 and A0 into A5 minus A0 into A5 by again A1. Okay. Then again what you will do? A1 into A6, A0 into A7, A1 into A6 minus A0 into A7 by again A1. So like that you need to crisscross, multiply and minus. See, again last you have A0, A1 into A8 minus A0 into 0. As there is no value, next value it is 0. A1 into A8 minus A0 into 0 by A1. This will become what? A1 by A1 into A8 by A1. No, A1 get cancelled, A8 you will get. For this, simply you have to get values like B1, B2, B3. There are some, we will get some values when you are doing with values. As we are considering the general characteristic equation, we are mentioning like this. Then again next what you should do, the same procedure you will follow for the next also. Now using these two rows you have done. Now what you will do, from using second and third row you will do. How? B1 into A3 and A1 minus A1 into B2 by B1. Okay. What will be the next? B1 into A5 A1 into B3 in between minus by B1. Again B1 into A7, A1 minus A1 into A8 by B1. This will become C1, C2, C3. After this, if you see, there is no value itself, A8. So this will become 0. Okay, this will become 0 and this will also become 0. Okay, then like that it continues. Then for next, what you will take, C1 into B2, B1 into C2 by C1. Then like that it continues till last you will do like that. After doing it, what we should check is, once the tabulation is completed, the next step in the application of the Routh criterion is to investigate the signs of element in the first column. What are the sign changes you need to find in the first column? What is that first column? This is the first column. I will mark now here. This is the first column. This A0, A1, B1, C1, D1, E1, F1, G1, AG are what? The first column. Okay. The Routh stability criterion is, for a system to be stable, it is necessary and sufficient that each term of the first column Routh array of its characteristic equation be positive. If you want to tell a system to be stable, the first column value is what you got. No, there should be greater than A0, greater than A0 greater than 0, means it should be positive. Then the system is said to be stable. If this condition is not met, the system is what? Unstable, and the number of sign changes of the terms of the first column of the Routh array corresponds to the number of roots of characteristic equation in the right half of the S-plane. As we know from the previous video that if the roots are on the right half of the S-plane, then the system is unstable. As there is some sign changes, when A0, A1, B1, C1, these all are not positive, then there will be some sign changes. No, either from, if for example A0 is plus, A1 is plus, B1 is minus B1, and C1 is minus C1. Okay, and D1 is positive D1. Then if you see the sign changes 1 times and 2 times. 2 times the sign changes means 2 roots are present on the right half of the S-plane. If you do problems, you will clearly understand. Just understand the concept first. The number of sign changes in the first column, either from plus to minus or minus to plus, that corresponds to what? The number of roots that are present in the characteristic equation in the right half of the S-plane, as the system is unstable. Now we will solve problems. So you will get a clear idea what is the Routh criterion, how to solve. There is a given characteristic equation of a servo system, some system. This is the characteristic equation. Determine the conditions which must be satisfied with the coefficients of the characteristic equation for the system to be stable. Here also they have not given the values. Without values we will solve. See, they are asking the condition, that's it. So from the Routh table what we can write? See, the Routh table, how you will write first? S4, S3, S2, S1, S0. You will write first. Then what are the coefficients? B0, B1, B2, B3 and B4. After writing till here, what you will do? B1 into B2 minus B0 into B3 by B1. The next one is B1 into B4 minus B0 into 0. As there is nothing, it will be 0. B0 into 0 by B1. So what we will do is, let us this will become B1, B1 cancel, you will get as B4. And next what you will do, you should multiply this with this. B1 into B2 minus B0 B3 by B1 into B3 minus B1 into B4. Okay, after doing that you will get the simplified equation like this, after simplifying it. Okay, till here you got. Then for the next there is nothing, no, there is nothing present here also, here also, so it will be 0 only. So next, now what you will do, you will multiply these two. B1 into B2 minus B0 B3, B3 minus B1 square B4 into B4 by B1 B2 B0 B3 minus 0. If you calculate this, finally you will be left with B4. Okay, for stability, all the elements in the first column of the root array must be what? Positive. Okay, so the conditions that must be satisfied for the stability of the given system. What are the conditions should be satisfied here? B1 should be greater than 0. This B1 should be greater than 0. B1 minus B2 minus B0 B3 should be greater than 0. B1 B2 minus B0 B3 B into B3 minus B1 square B4 should be greater than 0 and B4 should be greater than 0. If it is greater than 0 only, no, it will become positive. So these are the conditions need to be met. See how simple it is. We'll solve with some values so you'll understand still more clearly. We will see now. There are many questions present here, almost 5 questions. We will see one by one. See, by means of ROUTH criterion, determine the stability of the system represented by the following characteristic equation. For system found to be unstable, determine the number of roots of the characteristic equation in the right half of the S-plane. What they are telling? They are telling you to find whether the system is stable or not using ROUTH criterion. And if it is unstable, we need to find the number of roots which are present on what? Right half of the S-plane. If it is on right half of the S-plane only, no, it is unstable. Okay. Then, first equation we will take. In the characteristic equation, this is the characteristic equation, s power 5 plus s power 4 plus 24 s cube plus 48 s square minus 25 s minus 5 equals to 0. If you see, there is a negative present. The coefficients of s and the constant term are negative. Okay, hence the necessary condition for stability is not satisfied. So this system is unstable anyways. There is no need to form the ROUTH table to check stability. However, to determine the location of the roots in the S-plane, formulate the ROUTH table. See, just to find the stability, here all the coefficients should be positive. As the constant term and S term 25s, the coefficient of S is negative. Obviously, the system is unstable. No need to do ROUTH criterion table and find whether it is stable or no. We know that there will be sign changes. If you see minus, there will be sign changes and there will be the first column will be not positive. But then too we need to find the ROUTH table. We need to write the ROUTH table for what? To determine the location of the roots on the right half of the S-plane. What are the roots? How we will do? We will see now. S power 5, S power 4, S power 3, S power 2, S power 1, S naught. Okay, what are the coefficient for s power 5 is 1, for s power 4 is 1, for s power cube is 24, for s square is 48, and for s is minus 25, and for constant it is minus 5. We have written no now. Now after writing what we will do? We will multiply. How? 1 into 24 minus 1 into 48, 24 minus 48 by 1. We will get minus 24. Okay, then next 1 into minus 25 minus 1 into minus 5 by 1, you will get minus 20. In the same way, what you will do next? Minus 24 into 48 minus 1 into minus 20 by minus 24. So you will get 47.16. Then next, again what you will consider? Minus 24 into minus 24 into minus 5 minus 1 into 0 as it is 0 here by minus again 24. So you will get minus 5. Like that again 47.16 into minus 20 minus 24 into minus 5 by 47.16. You will get some value. Again to multiply this 47.16 to something, here nothing is there present here. Here also 0. So no need to multiply. Then you will get minus 22.54. Then minus 22.54 into minus 5 minus 47.16, this is 0 into 0 by minus 22.54. You get minus 5. As you can see, what is the condition to be the system to be stable? The first column of the ROUTH array should be what? Positive. As you can see, minus 24, minus 22.5, minus 5. It is unstable. That we got to know previously only. No, as the negative sign in the characteristic equation itself, it tells that the system is unstable. So we didn't form the ROUTH table now to find the stability here. We want to know the roots, the number of roots that are on the right half of this plane. So How you will get to know that number of roots which are present on the right half of the S plane? See, there are three sign changes. What are those? See, from positive to negative 1. Okay, from negative to positive 1. From positive to negative 1. Here again negative to negative. There is no sign change. It is minus minus only. So no issue. See, 1 positive to negative, negative to positive sign change, positive to negative. So three sign changes are observed. So s power rho to s power 3, see what I told first one, and s power cube to s square, second one, and s square rho to s1, s square rho to s1 is third. So in the elements of the first column of the root array, hence there are three roots of the characteristic equation in the right half of the S plane. So we have found that 3 are the right half of the S plane, so the system is unstable. Now we will solve the second question. There is a characteristic equation given as all the coefficients are positive. So there is a chance that the system may be stable or unstable. We need to find using root table. Root table, how you write? As the highest number is S4, S4, S3, S2, S1, S0 you will write. Then you write a coefficient. This is 1, 1, then 2, 10, 8, 3. After that what you will do? 2 into 10 minus 8 by 2. What you will get? 6. So 2 into 3 minus 1 into 0 by again 2. You will get 3. Then what you will do? Now first two rows are done. Now this you will multiply with this. 6 into 8 minus 2 into 3 by what? 6. So you will get 7 as the answer. Then 6 here 0 is there. So 6 into 0 minus 2 into 0 by 6, again it is 0. Okay. Then now we are done with third row also. Now we will come to fourth row. 7 into 3 minus 6 into 0 by 7. So 21 by 7 is 3. Okay, you got the values. As you can see, all the first column are what? Positive values. 1, 2, 6, 7, 3. All are positive. So all the elements in the first column of the root array are positive. What means it is? So the system is stable. So the system is what? Stable. So we will see the next question. Next question. As all the positive, so you can form the root table to find whether it is stable or not stable, right? As the highest coefficient is the power is s power 4. From s power 4 you write till s0. Then the coefficients are 1, 4, 1, 8, 1. Okay. After writing it, what you will do? You will multiply 1 into 4 minus 1 into 8 by 4. Okay. Then you will get minus 1. Then 4 into 1 and 1 into 0 by 4. You will get as 1. Okay. Now you are done with two rows. Now we will go to third row. Third row, what you will do? Minus 1 into 8 minus 4 into 1 by minus 1. You will get what? 12. Then minus 1 into 0, 4 into 0, as there is 0, minus 1 into 0, 4 into 0 by minus 1 again. You will get 0. Now we are done with 3 rows. Now we will go to fourth row. So 12 into 1 minus 1 into minus of minus 1 into 0 by 12. What you will get? 1. As you can see here, the first column, all the values are not positive. There are some, they've got one minus value. So we need to find how many number of roots are on the right half of the S plane. If you see, there is a sign change from positive to negative and negative to positive. There are two sign changes. So there are two sign changes in the elements of the first column of the root array. Hence there are two of the characteristic equation in the right half of the S plane. Hence the system is what? Unstable. Next question. This is the characteristic equation given. As all are positive, we don't know whether the system is stable or not now only. So we will find what? We will form the root table. First what we will do, we will write all the S4, S5, S4, S power 2, S power 1, S power 0 from the highest. Then the coefficients 1, 1, 1, then 6, 12, 18 and 6. You will write 1, 1, 6, 12, 18, 6. You have written, no? After writing it, what you will do? 1 into 6 minus 1 into 12 by 1. So the next what you will do? 1 into 18 minus 1 into this 1 into 6 by 1. You will get 12. The next equation, if you want to do also, there is nothing, so 0. Then now from the third row you should do 10 minus 6 into 12, 1 into 12 by minus 6. So what you will get? 14. So then 6 minus 6 into 6, 1 into 0, you will get minus 6 by minus 6. You will get 6. Now we are done with 3 rows. Now we will go to 4th row. Okay, 4th row. 14 into 12 minus 6 into minus 6 minus of minus 6 into 6 by 14. What you will get? 14.57. As if you want to multiply 14 into 0 also, there is no values here, so 0, 0, you will get 0 only. Then 14.57 into 6 minus 14 into 0 by 14.57, you will get as 6. As again, if you see in the first column, there are not all the positive signs. There is a negative sign, so the system is unstable. So how many sign changes? Positive to negative, negative to positive. 2 sign changes. 2 sign changes. So it means what? 2 roots of the characteristic equation are on right half of the S plane. Next question. If you see, it is from S power 6. So from S power 6, you will write till S power 0. All are positive coefficients. So we don't know whether the system is stable or not initially only. We should find the root table. 1, 2, 8, 15, 20, 16 and 16. If you do same way, 2 into 18 minus 1 into 15 by 2. 2 into 20 minus 1 into 16 by 2. Only you should divide the value, only this value. When you are doing with this value. When you are doing with this value, you will divide for all. If you observe 2, 2, 2. 0.5, 0.5, minus 33, minus 33, like that. Okay. The same way how I have done for the other 4 sums. Now you will do like that only. Okay. I am not repeating. Why? Because it is anyway the same method. If you see, there are some negative values present. So what it means, the system is what? Unstable. The first column should be what? All should be positive. So the system will be stable. As there is a sign change, it is unstable. So how many sign changes are there? Positive to negative, negative to positive, positive to negative, and positive to negative and negative to positive. 4 sign changes. Means 4 roots of the characteristic equation are on the right half of the S plane. So the system is what? Unstable. Okay. Now sometimes they may ask question in this form also. Is the system shown in figure stable or not? They'll give some figure like this. We have already seen, no, like block diagram reduction, closed loop system. This is input and this is output. As you know, this is the feedback. I'm just refreshing the concept. This is what the G value. Okay. Then G of S is what? Which is given 10 by S into S minus 1, 2S plus 3. As they are in cascade form, you can multiply 10 by S into S minus 1 into 1 by 2S plus 3. H of S is what? 1. Okay. As it is negative, what you will write? Here no need to write in this form, like a G of S by 1 plus G of S into H of S is not required. Here what we require to get the characteristic equation. The method here is 1 plus G of S into H of S. What is present in the denominator, no? That should be equals to 0. That is the characteristic equation. As you have G of S present, as you have H of S, they are not asking here transfer function. Transfer function means what? G of S by H of S, G of S by 1 plus G of S into H of S we will do. But you want the characteristic equation means what you should do? 1 plus G of S into h of s equals to 0, you should do 1 plus 10 by s into s minus 1 into 2s plus 3 equals to 0, you will do. After calculating, you will get some characteristic equation like this. In the characteristic equation, if you see, the s coefficient is negative. So the system is unstable. You got to know the system is unstable because the necessary condition for stability is not satisfied. Why? Because all should be positive or all should be negative. But there are almost all positive, only one negative, then the system is unstable anyway. So the system shown by the figure is unstable. Then, to determine the location of the roots, if we are asked to determine the location of the roots, then what we should do? We need to use roots table. How to find a roots table? S3, S2, S1, S0. The values are what? 2, 1, minus 3, 10. The same way what we did for the previous questions. 1 into minus 3 minus 2 into 10 by 1 equals to minus 23. You will get answer. Then here anyway after this to multiply there are no values. It will be 0. Then minus 23 into 10 minus 1 into 0 by minus 23. You will get 10. As you see, how many sign changes? Anyway you got to know the system is unstable. So the first column all are not positive. There is some negative. So sign changes how many times? Plus to minus and minus to plus. So 2 sign changes. So hence there are 2 roots of characteristic equations in the right half of the S plane. Okay. Next question. If you see using the root criterion system, the characteristic equation is given. You should find whether it is stable or not and comment on the location of the roots and also frequency of sustained oscillations if any. First we will write the roots table. Same like the previous, s power 4, s power 3 to s power 0 we will write by because the highest is s power 4. Then 1, 2, 6, 8 and 8 you will write. Then the same procedure what we followed will follow here. 2 into 6 minus 2 into minus 1 into 8 by 2 you will get 2. 2 into 8 minus 1 into 0 you will get by 2 you will get 8. Then if you see 2 into 8 minus 2 into 8 by 2 you will get 0 as the answer. And the next one anyway will be 0. Why? Because there is no values present here and here, as it is 0 and this is also 0, you will be 0. So if you see the whole row is 0, 0 and 0, which should not be the case. If all the zeros, then the system is anyway unstable. Why? Because there are symmetrical roots, located roots of the characteristic equation. So there is some difficulty arising. There are 2 difficulty arises. This is difficulty 2 arises here, as the whole row is 0 here. Means the system is unstable. At this time, what to do to find the location? Why? Because to find only just to find the stability, okay, you can leave it here. But they are asking to find the location of the roots. For that, what you should do is, anyway, this is 0. You know that in previous row there is values present. Then what you should do is, the row is what? 2s square. Then what you should do is 2 into this 2 into s square you should write plus, and you should not take next as 8s, not continuously you should not take. The next term you should take 8 into s power 0. Means what? 2s square plus 8. You should leave 2 values difference. 2s square, next you should take 8s0, not 8s. 8s power 0 means what? S power 0 means what? 8. S power 0 is 1. So you will get 2s square plus 8. We will see that in the next. See what I told. To determine the location of the roots from the auxiliary equation, what you will take? We will take some auxiliary equation as a of s. Some equation we are considering from the previous row, from the just above the row, just a row of the zeros. That should be taken, which are the row which is there as a 0. No, from that above a row only we should consider. After considering that, what you have written 2s square plus 8 is equals to 0. Okay. We need to take the derivative of this. D by ds of a of s. After taking derivative, you know 2s square. 2 into s square. D by ds of s square is what? 2s, that is nothing but 4s. D by ds of constant term is what? 0. So 4s you will get. So what you should do? You should replace these values. For the s term it is 4. No. So you will write in the place of here, in the place of 0 as 4. Till here you got. In the place of zeros, what you are doing? 4, and the next you have as 0. Now what you got? That this you got as a value. There is no 0 now present. Now what you should do? 4 into 8. 32 minus 0 by 4. 32 by 4 is what? 8. You got 8. Okay, replace this row zeros with the coefficient of the first derivative of the auxiliary equation. The equation what you get, you need to replace in the zeros place. Okay, after doing this, there are no sign changes. We have seen that there are no sign changes in the first row of the column, and hence there are no roots of the characteristic equation in the right half of the S plane, since the system is unstable. Why the system is unstable? Because you got two zeros in the same row. Okay, there must be roots on the imaginary axis of the S plane, which can be determined by solving the auxiliary equation. What we have solved using auxiliary equation, what we have done, 2s square plus 8 equals to 0. Using this, s square plus 4, if you take 2 common, you will get s square plus 4 is equals to 0. S square equals to minus 4. So s square is equals to s square is equals to, if you take squaring on both sides, s is equals to minus square root of 2. Okay, then you will get plus or minus 2j, plus or minus 2j or j2. Okay, so from this you got other two values which are there on the imaginary axis. Symmetrical equations are present on the symmetrical poles are present on the imaginary axis. I told. See, these are the symmetrical one. Plus or minus means minus j2 and plus j2. Their symmetry, no, the same value. See, when you plot it, you will get somewhere here plus j2 and minus j2 here. They are symmetry, no, equal distance. So only they are called symmetrical, present on the imaginary axis. So the system is unstable. Okay. So the system oscillates and frequency of sustained oscillations is omega will be what? 2. By j 2 is nothing but what? The omega value. To determine the other roots, two roots, factorize the characteristic equation. To find the other roots, what we should do? We know that this is s square plus 4 is what? S square plus 4 is what? One of the factor. If you divide this, in previous video we have done this. If you divide this by this, okay, then you will get s square plus 2s plus 2. After getting it, this s square plus 2s plus 2 in calci, if you do, you will get the other roots. That is s plus 1, 1 plus j1, s plus 1 minus j1. So other two roots are pair of complex conjugate roots in the left half of the S plane, which are on the left half of the S plane. Okay, these are all the roots. You need to find all the roots present. This why we have took to know the oscillations. This why we are doing to get to know the other roots present. As s square plus 4 is already a factor of what? This characteristic equation. So you can multiply that with some other value. That to get the other value, what you will do? The characteristic equation you will divide it with s square plus 4. The way we have done in the previous video only. I have done some problems related to this. So if you have seen that, you will get to know. You just check out if you have not checked. Then you'll understand how to do. Next question. By means of the root criterion, determine the stability of systems represented by following characteristic equation. For system found to be unstable, determine the number of roots of the characteristic equation in the right half of the S plane. See, they are asking for the stability, and if there is unstable, then we need to find number of roots. Characteristic equation the right half of the S plane. We need to find the number of roots present and what are the roots. Okay. First, we'll take the first characteristic equation. Same like the previous, you'll write the root table. I'm not going to repeat this. But if you see the 1, 2, 10, 25. But while doing, you will get here as 0. This is also difficulty. Why? Because the first one is 0. The second one is not 0. Right? So, for this, what you should do is non-zero element in the same row. So the test phase. So the system is unstable anyways. Why? Because you got 0 in the first. If you got 0 and 0 is also unstable. If you got the first column, 0 also is unstable. So to find the number of roots present, what we will do is the characteristic equation given, no, that characteristic equation will just replace s by 1 by z in the characteristic equation and form the z plane, not the s plane, z plane of the characteristic equation. How to do that? In place of s, 1 by z whole power 4 plus 2 into 1 by z whole cube plus 10 into 1 by z whole square plus 20 into 1 by z plus 5 equals to 0 you will write. After writing it, you will take the what? LCM. When you take LCM, this 5 will get what? 5z power 4. This you will get 20z cube. This you will get 10z square. This you will get 2z plus 1 equals to 0. For this equation, you will form Routh criterion table. As the z power 4 is the highest, from z power 4 to z power 0 we will do. Okay. Then you will write the coefficients 5, 20, 10, 2, 1. Then you will multiply 20 into 10 minus 5 into 10 by 20. 9.5. The other procedure is same like for S plane. You will get some values. If you see in the first column, anyway the system is unstable. No need to check the first column, first row, first column whether it is positive or not. But we should check for the sign changes. If you see here, it is positive to negative and negative to positive. So there are two sign changes in the elements of the first column of the Routh array. Okay, one from the z square and as I've shown. So hence there are two roots of the characteristic equation. The right half of the S plane and the system is anyway unstable. We need to find now those two roots of the characteristic equation. Then after that we will go for next question. The same way you will write the Routh table. Again if you see here, you are getting 0 in the first row while calculating. So it again the system is unstable. Now what you should do? You should replace s by 1 by z. Replace s by 1 by z in the characteristic equation. What you will get? 1 by z whole power 6, 1 by z whole power 5. 1 by z whole power 4, 2 into 1 by z whole power cube, 3 into 1 by z whole square plus 4 into 1 by z plus 5. You take LCM, you will get the characteristic equation like this. For this characteristic equation, you will write the Routh table. After writing the Routh table, no need to check whether the first column is positive or negative values. Why? Because anyway the system is unstable. Why? Because two difficulties arise. Why? Because the first in the row, first column value is 0 and the others have other value. So what you will do? You will just find the number of sign changes, that is positive to negative 1 and negative to positive 1. There are two sign changes. What it means? That two roots of the characteristic equations are on the right half of the S plane. The system is what? Unstable. Next question. For this also, you will write the characteristic equation. Again, if you check, you will get the value first column, first row, first column. The first value is 0, which is a difficulty 1 arise. If it is 0 and 0, then the all are 0, then it is difficulty 2. As it is first one is 0, it is difficulty 1. If only first one is 0, other has some value, then what you will do? You will replace s by 1 by z. By replacing s by 1 by z, you will get a characteristic equation by taking LCM. Again, you will write what? The Routh table. In Routh table, you will just find the number of sign changes. From positive to negative 1, negative to positive 1, two sign changes. There are two sign changes in the elements of the first column of the Routh table. So there are two roots of characteristic equation in the z in the right half of the z plane. It is z plane. Correspondingly, there are two roots of original characteristic in S in the right half of the S plane. So the system is unstable. Okay, the system is unstable. Next question. By means of Routh criterion, determine the stability of the systems represented by the following characteristic equation. For systems found to be unstable, determine the number of roots of the characteristic equation in the right half of the S plane. We will see now. We will see first characteristic equation. It is same like previous ones only. I am just making to do different sums because it will be easy for you, and all the sums in the textbook which have solutions I am doing, okay, so that it will be easy for you to attend exam. Any of these questions only will repeat, I can't say. This kind of questions will come, so you need to understand the concept and how to do, then only you can attempt in exam. You better write and practice, then it will be easy. After writing the characteristic equation, s power 6 is the highest. From s power 6 to s power naught you will write. After writing, if you see, the same way you will calculate 1 into 9 minus 3 into 1 into 9, sorry, 3 into 5 minus 1 into 9 by 3, that is equals to 2. Like that you will calculate for till here. If you see, you got a full row is of 0, means what, difficulty 2 is arising. So what you should do, the row which is above the 0 row, you should take the auxiliary equation. What is that auxiliary equation? 2 into s power 4 plus 6 into s square plus 4. You should not take 2 into s power 4 plus 6 s cube plus 4 s square. No, this is wrong. This is wrong. We should not take like that. You should take difference of 2. 2 into s power 4 plus 6 into s square plus 4 into s power 0. S power 0 is nothing but 1. So you got the auxiliary equation which I have already shown here. Now what you should do? After getting the auxiliary equation, we will take the differentiation of this. Differentiation of this will become what? 8s cube plus 12s is equals to 0. So 2s cube plus, that is 2s, you will take 4 common. So you will get 2s cube plus 3s is equals to 0. Now we should substitute these values in the rows which we got as 0. See, this is the 3 and this is the, sorry, this is the 2 and this is the 3 and 0. This is the row which we got the 0, no. So in this place you substitute the coefficients 2 and 3. After substituting, the same ROUTH table criteria only you will follow. 2 into 6 minus 2 into 3 by 2, 2 into 4 minus 2 into 0 by 2, like that you will follow. As already the system is unstable anyway, why? Because the difficulty arises due to all the rows are 0. Okay, so what it means, how many, there are no root changes. If you see here, there is no minus, here there is no minus. So to determine the other roots, divide the original characteristic equation by auxiliary equation. The same way, what we will do is, the auxiliary equation is there, no? You will divide this with the original equation. You will get some factor. What is that value? You will get again you should take LCM for this. If you take LCM, you will get as what, 2s power 4 plus 6s square plus 4 into this s square by 2 plus 3s plus 1. After doing this, if you take if you do some simplification, then by taking LCM and do and all things, then you will get this equation. From this, what you can do is s square plus 3s plus 2. If you find the roots, you will get s is equals to minus 1 and s is equals to minus 2. And for s power 4 plus 3s square plus 2, if you find the characteristic equation, okay, from this, if you want to find the roots, you will get two roots again, that is plus or minus j1 and plus or minus j root 2. So these are there are two pairs of non-repeated loops on the imaginary axis. See, there are two pairs of non-repeated loops. This is one imaginary pole, this is one imaginary root. There are non-repeated. For example, if it is plus or minus j1 once and plus or minus j1 second, then it is a repeated. Which is, this is not repeated, different roots, no. So the system oscillates and it is a marginally stable. Marginally stable. Marginally stable is, anyway it is unstable. As there are only on the non-repeated loops and the imaginary axis, what it means, and these are on the what plane? On the right half of on the left plane. So it is marginally stable. Okay. Next question. B. Same way you will write the rows table. You will calculate in the same way. After calculating, you will get the whole row 0. When you get whole row 0 at some point, that whole row 0 above row, what you should do, you should take the auxiliary equation. Auxiliary equation is what has what s square. So s1 into s square plus 1 into s power 0 is equal to 0. S power 0 is 1 anyway, so s power s square plus 1 is equal to 0 is the auxiliary equation. So from the auxiliary equation, if you differentiate, you will get 2s plus 0. So this coefficients you will mark in the place where you got 0. Okay, 2 and 0. 2 and 0. You will write. After writing 2 and 0, you will get 4 into 8. 8 minus 4 by 2. You will get 4 as the answer. 4 as the answer. After getting it, all the elements in the first column of the revised root table are positive, which indicates there are no roots of characteristic equation in the right half of the S plane. As all are positive, there are no roots on the right half. Still the system is unstable. So we need to find the other values. Take this auxiliary equation, s square plus 1 is equal to 0. So s is equal to plus or minus j1. Okay, to find the other roots, this is the omega. What omega means, something but oscillating frequency, omega equals to 1. To find the other roots, we need to factorize. Using this auxiliary equation, you will divide it what? This auxiliary equation. This is s square plus 1. You will divide the whole characteristic equation by s square plus 1. Then you will get s square plus 1 into some value. Using the calci also you can find the roots, or else using calci you can directly find the roots. It will be easy for you. Why? Because it is anyway SAQ. That video I have already done in the previous topic, how to calculate the using calci the roots. You can check it out. So using this you will find the two roots, s square plus 1, s plus 1, or else what you can do using the substitution method, like in the place of s, if you put minus 1, then you will get 0. So one of the factor will be s plus 1. Again you should divide this s plus 1 by this, then you will get s square plus 3s plus 4. Then what you can do, using the calci, you can calculate the other roots. So you will get 4 roots present on the axis. Okay, this is the way you need to find the different roots present on the axis. Next question, determine the stability for a linear system shown in figure. As there is an unknown value k, we need to find the value of k range. So we will see how. The same type of problem I have already done in this video. This is a question paper problem, so that you will understand how to do. That you should not feel you don't know how to do. So I am doing a question paper problem also. If something like this, you need to find a k value. So 1 plus g of s into h of s will be 0. That is a characteristic equation for a if there is some diagram like this given. So g of s is given and h of s is given. So if you substitute, then by simplifying you will get a characteristic equation. For this characteristic equation, you are going to write what? The root stability criterion. For using root criterion, s power 4, s power 3, s power 2, s power 1, s power 0, 1, 5, 5, 4 and k0. So 5 into 5, 25 minus 1, 25 minus 1 by 5 means 21 by 4. So 5 into k minus 1 into 0 by 5. You will get k as the value. Okay. After doing this, next 21 by 5 into 4 will be 16.8 minus 5 into k by 21 by 5. The next value anyway it is 0, so it is 0. Then 16.8 minus 5k by 21 by 5 into k by minus 21 by 5 into 0, it is 0 by 16.8 minus 5k by 21 by 5. You will do. For that, lastly you will get the final equation what? In this way. If you see, this 21 by 5 and this 21 by 5 get cancelled, and 16.8k minus 5k into k by 16.8 minus 5k. Okay. So this 16.85 minus 5k will go to right side, it will become 0. So anyway, using this equation, you know that k is greater than 0. One value you got. Next other value is what? Then 16.8 minus 5k is greater than 0. So k will be greater than what? 3.36. If you calculate. If 5k is sent this side, k is equals to 16.8 by 5, we get 3.36. Then the value is from the range of 0. K should be greater than 0, first one. Then k should be greater than, k should be less than. Okay, k should be less than 3.36. Okay, I hope you understood. K should be less than 3.36. I think I have did wrong here. K should be less than 3.36. Just change this. What I write with the black pen. K should be less than 3.36. Why? Because if 5k is sent this side, 5k, okay, 5k, this greater than will be like this only, 16.8. So k will be 16.8 by 5, greater than k. So k will be what? Less than this value. So k should be less than. So by mistakenly I have written greater than. So it is for the last derivation, for the last equation I have written correct. Should less than. Okay, less than. So less than 3.86. So the system is stable as first column of all the positive values, all are positive values. So the system is what? Stable. And the range of k is what? 0 and 3.36 is also shown. So in this video, what I have done, Root stability criterion, and many problems have solved. There are much more problems you can find out using some sources. Then you can solve them, so that all the sums are similar. What you should do, root stability means they'll give a characteristic equation. If there is like one row, if it is 0, whole 0, then what you should do, you will take the derivative and you will find the auxiliary equation. No, if it is not like that, only first one is 0 and other rows have some values, then what you should do, then what you should do, the main equation will be there, no, the main characteristic equation in the terms of s. In the terms of s, you will be substituting in the place of s as 1 by z, and you will take LCM. For that z plane, you will write the Root criterion. So you should practice anyway. It will take time. If you practice only, you will understand. So by this, I stop the video here. Use the Root stability criterion. The relative stability analysis is remaining in this module. Okay, if I complete this, the chapter, the whole module is done. So by this, I am stopping the video. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.